Hi, my name is Ekaterina Vydra, and I'll be doing a proof by contradiction, where we take a statement and we assume the contrary of that statement, and then use logical and algebraic steps to prove that there's a contradiction with our assumption. The problem that we'll be looking at is the one right here, which states there are no positive integer solutions to the Diophantine equation x squared minus y squared equals 1. For this, we will assume the contrary, so we will assume that there's an a and b that are integers where a squared minus b squared equals 1, and where a and b are both positive. So once we assume that, we can factor the original equation to get a squared minus b squared equals 1 to a minus b multiplied by a plus b equals 1. So notice that we have a product of two expressions that equals to 1, meaning one side of one expression needs to be the inverse of the other. So one solution would be an inverse pair that equals to 1. So since we define a and b as integers, the sum or the subtraction of those integers would make an integer, and the only inverse pairs that exist that are solely integers are 1 and 1 and -1 and -1, which would mean that a minus b would have to equal to 1 and a plus b would have to equal to 1, or a minus b would equal to -1 and a plus b would equal to -1 also. So when we solve for a and b in both of the cases, we see that for the first case of a minus b equals 1 and a plus b equals 1, b ends up being 0, and when we plug it back into a plus b equals 1, we see that a is equal 1. But since b is 0, it's not positive, so that throws that one out. For the other one, both of the variables a and b end up not being positive, meaning the only integer solutions that we got don't give us positive integer variables.
So, since we have reached a contradiction with our initial assumption, the opposite of that assumption has to be true. Therefore, we can finally say with all certainty that there are no positive integer solutions to the equation x squared minus y squared equals 1